Just a good old smash, never meaning no harm. Beats all you'd never saw, been in trouble on social media since before its existence. Straightening facts, smacking down hacks. Someday our viewers might get me, but the tech never will. Making my way the only way I know how. That's just a little bit more than the tech will allow. Just a good old smash, wouldn't change if I could. Fighting the nonsense, it's a neo-renaissance in the hood.
And welcome everybody to the Daily Space Weather. We see solar activity has dipped big time. Coronal holes. Comments. And thanks everybody for leaving comments. And thanks to our viewers. Whether you're viewing on YouTube or BitChute or Twitch, cheers, thanks for tuning in to another episode of the Smashes of Hazard. And by the way, if you'd like some merch themed with the Smashes of Hazard, well, we've got all kinds of stuff, including even a mini skirt. If you'd like a mini skirt with the Smashes of Hazard brand new design, or perhaps an iPhone case, 67 plus products, perhaps a Smashes of Hazard clock, might be something to put on your list. And we've rolled out that new merch. More about that at a later point. First, more images of the local yellow dwarf here. Major coronal hole system ahead of that former sunspot. I don't know why it never got a name. It was certainly there for more than 12 hours. For some reason, sunspot 2802 was just passed over for sunspot naming conventions. Huge filament there in between the coronal hole and that active region in the southeast. And it's still holding on for the most part. At least part of it has rained back down into the chromosphere. But in any case, we can expect a pretty significant coronal hole wind stream from this coronal hole down here. A cool area in the sun's chromosphere that lacks plasma and gives insight into the solar magnetic fields. That's South Pole oriented. And we're going to show you a close-up of that in multiple wavelengths momentarily. First, a diagram of the solar system. And let me just check the life of the stream. We are streaming live to Twitch right now. And thanks for tuning in. And leave it a comment, Life Force Rejuvenation, who says, Grand Rising. And there's where things will be in 1 week in the solar system. Here's a star chart. I like to use in-the-sky.org, and I draw in the ecliptic, which is this yellow line. Just come down here and click ecliptic. Put in your own location, and it'll tell you what stars are above head right now. As Cygnus circles Polaris over and over and over again. Hey, look, it's the brightest intrinsic object visible from Earth in the Milky Way galaxy. It's Deneb. The 10.7 centimeter radio flux, a measurement of the outer solar corona, has dropped all the way down to 70 solar flux units. Very low levels. Now, just a quick aside here. Solar activity seems to be governed by the sun's magnetic fields. If you head to solon.info/solar, you can find all kinds of information about that. This was updated last on just over a month ago, and that's just a text update. This graph is quite old here, and we're waiting for this graph to be updated because the magnetic field activity is pretty important as to whether we'll be seeing a weaker solar cycle or a stronger one here in cycle 25. Anyway, there's the 1-year chart to put the radio flux in context. That is a 1-year chart. The black line up top is the radio flux, and that is proportional to sunspot number. A little more information about the solar polar fields. The Wilcox Observatory has a graph about this. Sadly, it only goes back about to my age, back to 1975. I was actually born in 1976, and I guess I'm dating myself, and allow me to vanish so you can see the whole graph. And this is smoothed data here. So what you're looking at is the north solar polar field, the south solar polar field, shown in blue and red respectively, and then the net field, which is the black line. And this has to be smoothed because as the Earth orbits the sun, there are variations in the actual magnetic field measurements, and this has to be interpolated through math to come up with this graph. So if you want to look at this yourself, head to the Wilcox Solar Observatory, and this link down here is I believe it's the mean field, and then you got to click on solar polar field strength table, or GIF. I think it's the GIF. But in any case, that's going back about 45 years, that is the solar polar field behavior. And this is probably one of the most important graphs in terms of forecasting future solar behavior. Here's the sunspot number progression and the radio flux through the last solar cycle. I don't want to get too in depth into that, as that would be for a cosmology segment or a heliophysics section, as opposed to the daily space weather. So here's the only HelioViewer movie we made today. And this is a spectacular 2 different wavelengths here, looking at 193 angstroms as well as 304 angstroms. I made a fade here to do a close-up of this active region, a coronal hole, and a massive filament. So fantastic view of that. And I don't know what went on with helioviewer.org, but something funky was going on with helioviewer.org. And it caused me to have to go to a different site, and I'm not going to get into it in the daily space weather video. Here's yet another image of the sun. Here's the 304 angstroms full disk view, and you can see some of that filament being sucked back down, it looks like. There were no coronal mass ejections, and we've also got significant filaments in the northwest. Also an active region, looks like it's rising in the northeast. So you probably don't have too long to wait to see some other interesting features on the sun. And we'll show you more images of the sun at the end of the video. First, we're going to cover volcanoes, which is why we're at volcanodiscovery.com. So for today, February 10th, what's on the list as far as eruptive behavior, volcanism, is Mount Abiko. It's producing a 10,000-foot ash plume. I think it's an uptick at Abiko. Sakurajima exploding, which is on the Isle of Kyushu of Japan. 7,000-foot ash plume there. Raung, you wouldn't be wrong to say Raung is exploding and producing an 18,000 volcanic plume of ash and fertilizing the soil downwind. Sinabung, the deadliest volcano of the past few years, also erupting. Flight level 150, it's a 15,000-foot ash plume. Sangay, 21,000-foot ash plume as it explodes. Ravenador also exploding, 15,000-foot ash plume. And Sabancaya exploding. Flight level 240, it's a 24,000-foot ash plume, which is nothing to attempt a pole vault over. Please do not attempt the Fosbury flop over any volcanic caldera. We need the we need the views on YouTube. We don't see any major quakes. The largest quake of the past 24 was only a 5 magnitude. There was a deep quake in Chile, nearly 100 kilometers at a 4.8 magnitude. Here's a deep quake in the Banda Sea at a 4.5 magnitude at 172 kilometers depth. Here's a very shallow quake under Hawaii, and we regularly report these shallow quakes. It looks like it's under Mauna Loa, and indeed, almost directly under one of the sub-calderae at Mauna Loa. The depth of that quake is negative 1.5 kilometers, so 1,500 meters above sea level. The depth of that quake, it's a negative depth. That would be like 4,500 feet of altitude. A quake in the Congo, not a normal spot for an earthquake there. Deep into the African craton. Here's another deep quake in Peru. So pretty much a mild last 24 hours of earthquakes. I stand corrected. The largest of the past 24 was this 5.6 at the Central East Pacific Rise. A 5.0 did strike El Salvador in Central America. By the way, if you follow us on other social media, you may see our Instagram page, instagram.com/smAsho, and we've just linked to this photo. This was last night's dinner. It's taco salad, and we had homemade cheese sauce. And thanks to Smash staff for updating the forum. If you've never been to smashomash.com/forum, check it out. It's totally free. If you'd like to post anything, just create a login. And we linked to that because we're wondering if anybody wants our recipe for taco salad. If so, there's only one recipe there now. It's for our homemade chili. It's a Tex-Mex theme. There is guacamole and homemade cheese sauce involved with the recipe. So visit our website, smashomash.com. You can find our social media links there as well as links to our stores. And we've updated the smAsho merch shop. We've improved all of the designs and added a couple products and removed a couple of products from there. So check that out. The Redbubble shop, it's redbubble.com/people/smashomash. And we've added the Smash of Hazard theme. We've also put the Fauci fraud bath mat. If you'd like to put your feet on Fauci's face every time you get out of the shower, then pick up one of our Fauci committed fraud bath mats and put your feet where they belong, on the ultimate fraud on earth, Dr. Fauci. The biggest fraud there is, who's continuing to work for the government, and I don't know how much cash he's collecting based on vaccine royalties. He has a patent, and I'm not going to get deeper into it. You can visit all of those links from our homepage, smashomash.com. This Smash stream was streamed live to Twitch, twitch.tv/smashomash, thanks to our new follower over on Twitch. Our main content is located at YouTube, so please press like and subscribe, as the video cannot continue and the place will continue to burn until you press like and subscribe. So please do, because we can't afford a fire extinguisher. So don't worry, you can press pause and we'll be here when you get back. It's the beauty of video on demand. Press the share button, share on your social media, as we need your assistance to get the videos out there, as the algorithms are not exactly helping. YouTube.com/smashomash. Visit our playlists as well. And don't forget to follow us on Twitter. We've put up a new poll. So this is a 5-day poll, and we're interested in knowing who you trust more, legislators or a potted plant. Now, with all of our Twitter polls, we always, after the poll is complete, I always put a comment in there explaining what I would have voted for. So who do you trust more? Are legislators or a potted plant? We're also on BitChute, thanks to our new subscribers over on BitChute. There's exclusive content there as well, as if any content gets demonetized on YouTube, we put it to BitChute. Next, thanks to our patrons, as we make just this side of nothing by putting the videos on YouTube. Patreon.com/smashomash if you'd like early alerts and all kinds of perks. Patreon.com/smashomash. Thanks to our patrons for enhancing the probability that these videos will continue to not only exist, but be free, timely, and publicly visible. Today's cosmology segment's going to be pretty brief. Yesterday's we actually clipped, and I would like to get to a comment. Somebody posted a comment here, ellipsis truncate the resistance video, put up a comment and said, in case you are not subscribed yet, See the Pattern has released a new one. Transmutation of elements in body again. Awesome research. Now that you've pressed like, subscribe, share, and notify, we can put the fire out. Now, Gareth of See the Pattern has been on this channel. We did like an hour-long conversation about some just random cosmology topics and so on. So let me read my response to this. In case you are not subscribed yet, See the Pattern has released a new one. Transmutation of elements in body again. Awesome research. Now, as far as his biology videos go, I don't know. I don't watch them and I don't care. As far as his cosmology videos go, they are ridiculous, ridiculous, pathetic nonsense. So, let me read my response. Ha ha ha! I've been laughing into that washed-up fanboy Gareth's face ever since he cried about his inability to explain where the electrons come from in his nonsensical electric star model. You know, the one that's not backed up by observations, only imaginations. Gareth is a joke. Most of his videos are nonsense cubed. And here's one of my many, many other criticisms. If you can't explain your theories in simple terms, you probably don't understand your own nonsense. I would not associate with a hack like Gareth. He's an infantile mind who doesn't even understand the plasma cosmology, much less the theories he thinks he's debunking. Stars aren't electric, no matter how many pretty animations Master Gareth creates. It's idiotic. So I figured I'd include that in today's cosmology segment because the channel See the Pattern is fully pathetic. And what this comes down to is an argument that we had that caused Gareth to say, I don't want to talk to you anymore. Why? Because I asked him to explain his nonsense about his electric star models and said, hey Gareth, where do the electrons come from? And he said, I don't want to talk to you anymore because you don't read. You don't understand Don Scott's electric star model at all, do you? And indeed, I don't understand it because it's backed up by nothing but imagination as opposed to observation. And by the way, searching around for stuff in nature to prove your theory is correct is not science. It's dogma. So we've got cosmology segments on our channel where we don't talk about complete nonsense like expanding moons. So I just figured I would go there and let's talk about some cosmology. So I've just included this once again. I wanted to just briefly touch on this again. The local chimney is moving toward that bright spot in the Milky Way galaxy. That's Deneb over there, somewhere in the Cygnus arm of the Milky Way galaxy. With respect to the other stars in the local chimney, the sun is moving in this direction. So as a whole, all of these stars in this local chimney are moving toward Cygnus. But the sun within the chimney is moving in that direction to the solar apex. If you want to visualize this yourself, head to plasmascape.com. You can find all of that yourself. Just press A to bring out these tabs. This is number 5, and there are different zooms if you want to zoom in to the solar system. There's a zoom in. And Plasmascape, it's a great visualization tool to understand a little bit about cosmology, astrography, the locations of things. Let's pick a random number with our quantum random number generator. Today's random number is 370. So we'll head to the Neil Garrel's Burst Alert Telescope and see what number 370 is. Number 370 is Quasar J1130-1449, which is actually a blazar. So it was originally named a quasar, but it's actually a blazar, indicating that one of its poloidal jets is pointed directly at you, the observer, here on Earth. So here are the X-ray transients from blazar J1130-1449. And I think blazars are one of the most important aspects of cosmology, as blazars are examples of likely extragalactic cosmic ray sources. So There's a project that I'm working on that I can't really divulge because I don't want anybody to steal my ideas. But in any case, here is a view of Blazar J1130-1449. That's the Simbad view. And let's go to Aladdin Light to see some additional wavelengths, as that would be visible. That's the optical band. Let's take a look at the infrared band on the 2MASS. So there it is in infrared, and let's see if it shows up. There it is on the Chandra X-ray telescope. So you can see it's quite bright in X-ray, and the reason is because you're looking straight down the field. So if you had a better view of this, if you were viewing it slightly from the side, this might look like a spiral galaxy. But because you're looking directly down the pole of that galactic core, it looks very bright. It's very bright in X-ray and so on. It's Blazar J1130-1449, and it'll probably be featured on today's thumbnail. As perspective is everything in space, let's talk about some perspective from a previous cosmology segment. If you haven't checked out our playlists, there's a playlist for cosmology segments on our YouTube channel. It's youtube.com/smashamash/playlists. You'll find a bunch of playlists there. And one of our cosmology segments is about a neutron star comet. Yes. Now, this comet discovered back in 1996 because of occultation. Somebody was looking at objects, right here, and something was in the way of them or distorting their image. And they said, what the heck is that? So a couple years later, they noticed that the object was way over here, moving at somewhere around 200 kilometers per second. It's massive radio source J185635-3754, a neutron star. I'll just refer to it as a massive radio source moving through the galaxy at hundreds of kilometers per second, much like a comet. Again, youtube.com/smashamash/playlists. You'll find a bunch of playlists there, and that's today's cosmology segment. The cosmology segment is don't be a complete noob face when it comes to cosmology. And thanks for your comments, John, aka Life Force Rejuvenation, who says, thank you to our #1 badass logos observer this side of the universe. Our #1 doe. I don't know what that means, but thank you anyway for leaving comments. Let's get back to data. The GOES X-ray flux is looking pretty flat here over the past 3 days. No solar flares. And we're back to 0 sunspots, it looks like, as I didn't see any umbrae associated with what should have been named Sunspot 2802. And no proton strikes either, no coronal mass ejections in the past significant period of time. And allow me to get back off the screen and show the real-time solar wind. And we just saw a shift in the phi angle. So some shifts in the phi angle here over the past 12 hours. The BZ has just dropped into negative territory here. That is the South Pole coronal hole, by the way. Current solar wind density around just under 5 protons per cubic centimeter. Solar wind speed, 438 kilometers per second. Pretty background levels there. The KP index, a measurement of global geomagnetism, is at 1. Here's 4 hours of geospace movie. It's a geospace magnetosphere movie. It's showing you magnetohydrodynamic pressure in nanopascals. And let me advance that to where it was. We don't want the video to be too long, as it's the daily space weather. So that's 4 hours of data, nothing to write home about there. No major changes in the pressure, as it's been a fairly steady solar wind speed and density. Small uptick right at the end. Now we're looking at ground magnetic perturbations, and we're looking at this daily since we are in a current geomagnetic excursion. We've got 2 north poles. The South Pole has left the Antarctic continent entirely and went into the Indian Ocean, somewhere south of Australia. Anyway, that's 4 hours of data of ground changes in the Earth's B field, otherwise known as geospace delta B. Here's the GOES magnetometer over the past 3 days, and we're seeing pretty low readings here once again. Keep in mind there is a significant stream of plasma headed our way as a result of that South Pole-oriented coronal hole. That's 3 days of data from the GOES 16 magnetometer, and those arc jet moments are the GOES 16 using its thrusters to maneuver, creating plasma and possibly getting bad readings. So it refers to those arc jet moments. Next, we're looking at the hydrogen alpha lines here from the El Teide National Sunspot Observatory location, El Teide, Spain. I'm going to blow this up. And that filament is still hanging out there. Next, the top view ecliptic plane field plot. We're looking at magnetic data for the heliospheric current sheet. The Earth is solidly in the South Pole-oriented one, and we're going to see some significant changes here in the GOES magnetometer. Don't be surprised to see some wild spikes before that coronal hole wind stream arrives, as we've got a dense plasma filament seen right there in red, and we'll be in the South Pole current sheet for the foreseeable future here on planet Earth. Please leave us a comment if you're viewing from a different solar system, galaxy, timeline, plane of existence, etc., spaceship. We're more than interested in your stance on things like heliophysics. Next, looking at a line of sight field plot. This shows the solar magnetogram as well as the sun's B field and the poloidal fields. So check it out. Here's the north Z field. It's the north Z field. And here's the south Z field, the poloidal fields. And by the way, if you're wondering what the B field is, well, the B field is a combination of these fields. So here's the south and north pole poloidal fields, and the degree to which these overlap is the B field. And without going further into that, let's move on to the coronal hole line of sight field plot. And you can see that large south pole-oriented coronal hole there. Just moving into the Earth-facing zone, it's going to provide a significant coronal hole wind stream. Don't be surprised to see a geomagnetic storm from that. Here is the coronal magnetic field plot, the magnetic field plot of the sun's atmosphere. A chaotic place indeed. It's showing you open potential field surface source lines in black or purple, and closed ones in pink. Nothing to really comment on there. Here's a diagram of the atmosphere. It's in kilometers, and we show it daily to show you where the GOES 16 is. It's around where that red F on the right is. It also shows you penetration of electromagnetic radiation from the sun into the atmosphere. For example, visible and infrared light is pretty much the only band that makes it all the way to the surface in a large portion. X-rays are largely adsorbed by the time they reach the stratosphere. Here's another diagram. This one's in miles instead of kilometers. It shows you things like the Van Allen belts, which are belts, giant belts of electrons that surround the Earth. And where do those come from? Well, probably from condensed matter, but we won't get into it today. We'll just talk about readings about electrons. Electrons can charge up satellites, and we don't see any of that happening right now. No charging hazards are going on. Here's a 3-day chart of the electron flux. It's the GOES 16 greater than or equal to 2 mega electron volts. And those are some high energy electrons, but there aren't that many of them. Here's a 1-year chart from Solon.info to put it in context. Here's me checking the life of the stream. And here's a visualization of the total electron content. The most GPS errors that you would expect to ever see on Earth would be around noon at the equator. And this will show you anomalies. I'll let it play through a second time for once. And we do see some anomalies here. We see some significant electron densities here at nighttime. And that's a reason to have Wi-Fi location accuracy turned on, especially around the equator at noon. Here's the relativistic electron content forecast, the relativistic electron forecast model. And the forecast is for a little uptick here, actually for it to remain level. And no comment on that. The green boxes are the forecast and the yellow diamonds are the observations. And you can see sometimes they're way off. And sometimes I'm way off with the electron content forecast. And the electron content is not fully understood in terms of the physics. So next we're looking at just a visualization of one layer of the atmosphere. It's just the ionosphere by itself. It's actually looking a little bit anomalous here. At least at the beginning of the video. Anyway, here's the latest image. That one coming in at 10 o'clock Universal Time. And like the electron content, you would expect to see the sun right about here, just ahead of those highest frequency portions of the ionosphere that's measured in megahertz. Next, looking at some meteorology stuff. We're on nullschool.net. It's looking at the jet streams, which are tripled up over the northern hemisphere and the eastern portion of the planet, and all over the place in the southern hemisphere. Look at this extreme bend down here. Extreme bends in the jet stream, folks. Is it caused by the galactic current sheet? Well, the answer is no. Because the galactic current sheet coming out of the core of the galaxy is no place near us. It's tens of thousands of light years away. And anybody who tells you otherwise is either ignorant or lying. Because a material misrepresentation of facts, if it's done intentionally, is what we call fraud. Jet streams of the Western world are extremely chaotic. Look at the Pacific Ocean. It's got a tripled up jet stream which even crosses the equator. The jet streams of the Western world are indeed all over the place. Check it out. It is extreme jet stream flow, to say the least. And if you're wondering what we're looking at, it's nullschool.net's 250 hectopascals wind. Yowzers. If you see the jet stream blowing east to west, that's backwards. Next, looking at pressure cells and high pressure dominating the entire North Polar region once again. This is windy.com's pressure map. Here's where we expect pressure to be tomorrow at 12 noon. A powerful low pressure system over the North Atlantic could create some unfortunate seafaring conditions in places like the British Isles. Also a powerful low in the North Pacific, as high pressure continues to dominate the North Arctic region. Here's a U.S. Doppler radar map. It's the current stuff. Check out the ice storm stretching all the way from Texas to Kentucky. Is it sleet? Is it freezing rain? Leave us a comment. Let us know. And we don't see any terrestrial lightning right now. I like to use lightningmaps.org when I hear thunder. And here's a snowfall forecast on Tropical Tidbits. We're going through to Saturday, February 13th. It's a GFS forecast. That's 1800 Universal Time, which would be 1300. So this is 1 p.m. on Saturday, according to the GFS forecast. Incredibly heavy snow there in northwestern Oregon. Look at that, 33 inches shown on the chart. Some additional snowfall to happen. The epicenter of the eastern snowfall will happen in the easternmost portions of West Virginia. And I won't go any farther than that, because if you're more than about 4 days out with a forecast, you have no idea what you're talking about, and neither does the model. And we won't get into any specific forecasting today. I did want to note that the snow mass balance has moved to a standard deviation above the 30-year average. So this is the northern hemisphere snow mass balance. This would be the 30-year average from 1982 to 2012. And the last couple of weeks have sent it completely outside of the 1 standard deviation range. So we're over 1 standard deviation above normal snow mass balance. Keep in mind this does not include mountains. So any snow on mountains is not figured in with this, as there are problems with calculating the snow mass. You've got to figure out the altitude of the snow to create this calculation. Here's the snow water equivalent. So once again, outside 1 standard deviation. There's the snow extent tracker. So the extent isn't all that high. It's actually in the normal range. It's actually kind of toward the low end of the range in terms of extent, but the snow mass is actually over 1 standard deviation above normal. And the last 3 winters we saw 2 standard deviations above normal for this. This time only 1, and once again my forecast has been correct all winter. I've been calling for this winter to be a little bit more normal, as 2017 to 2018, 2018 to 2019, and 2019 to 2020 all featured 2 standard deviations above normal snowfall. And here's just a visualization of the total snow cover. Boy, oh boy, it must be so hot that it's cold. All that carbon dioxide, it must be causing the planet to warm up, which is why the northern hemisphere has that much snow on it. Here's what's going on in the cloud layer over the U.S. Here's a water vapor map of the same area, I think. They got me. Here's a water vapor map for the same region. And the main moisture is in places like Nebraska. A little bit of an atmospheric river forming there in between Arizona and Missouri. Moving into Iowa, Illinois, and Wisconsin. Thanks, smAsho team, for tuning in. We've got bonus features. Please don't forget to press like and subscribe on YouTube. Share with your friends, share with your foes. Tell everybody so everybody knows about the channel. The bonus features are going to include a colorized magnetogram and an intensitygram, which will likely show you 0 sunspots. We're going to zoom in on what used to have ombre and now no longer does. It was a sunspot. I don't know why it didn't get named, but in any case, it didn't get named. So 0 sunspots right now. We do see an active region rising in the northeast. Here's a close-up of the most active area in terms of magnetic organization. And we'll show you a couple more views of the sun here. We'll show you 171 angstroms and a composite. And just bear with me one quick moment as I vanish. Here's 171 angstroms. And we'll zoom in on the southern hemisphere here momentarily. Speed that up a little bit. Great view of that filament. And it's still suspended there, folks. It has not collapsed yet. It might be in the state of collapsing now. And last but not least, here's a composite view. This is 211, 193, and 171 angstroms. Again, there's an active region rising up here in the northeast. And let's zoom out to close things out on a full disk image. Thanks again for tuning in, folks. See you next time on the Daily Space Weather. And may that solar wind be at your back and that covidiocy absent from your YouTube feed.